Today we are going to carry on with memory caching by looking at some exercises. So, we had a look at some direct memory caching. In this example we're going to have 16-bit addresses and we're going to have 4 64-byte blocks in the cache. Now remember, that would mean that the tag is 8 bits, the index is 2 and the offset is 6 bits. So when we start, all the valid bits are cleared and we have no data in the cache. There's also no block, or we have blocks but we don't have any tags or anything like that. So we see a setup like this. So we have block 0, 1, 2, 3, and that makes sense. We have an index of 2, so that means we can only represent 4 different blocks. So none of these are valid because no memory has been put in there. We've just started up, so all the valid bits are cleared. We have no tags and no data yet. We only set the valid bit when it contains valid data. So what happens next? Well, what happens next is we get an access with an address like BA98. So what we do is we split this up. So we split it up into the tag. So we have this bit here, and this becomes the value BA, which you can just read off of here because this happens to line up on a word boundary. So we have 1010, 1011, so that's BA, and that goes in the tag column. Now we need to get the data, but this is set to yes because it will contain valid data. So how do we get the data? Well, we have an offset of 6 bits here, and this tells us where in this range of memory this bit would be. So we have BA98, and this offset is 18, and so that means we have to subtract 18 from the BA98 to get the lower end of the data, and then we add 64 bytes onto that to get the top end of the data because this is a 64-byte block. So subtracting 18 from BA98, we get BA80, and that's the lower end of our data. And then we add 60 or 63 onto that, so we get 3F. Remember, because 80 itself contains a byte, so to get 64 bytes, we go up to the next 60, or we go 63 up, and that takes us to BABF. So we now have a 64-byte range of data which has been loaded into the cache. Now, when we got this access request, there was nothing there, so we get a miss. And we refresh the block. So we missed originally because there was no data there, and we refresh the block, which puts a tag in there, sets the valid bit, and brings this data in. So although we now have a range of data in there, originally when we got the access request, we didn't have data there, so it counts as a miss. Now, if the required data is not in the cache, a miss occurs, and we have to get that data from memory. So we refresh it from memory by getting in the correct data to the cache. Now this takes time, and this can often slow down the performance of a processor if it's often having to refresh, and this is one area of where you need to worry about efficiency with the miss rate of your cache requests. So let's look ahead and do some more examples. So let's look at BABC. So again, we write it out in binary and we split it up. So this one has as its tag here BAB, or BA, sorry, again. So we might have something in the right range for over here. Its tag is 10, so again it would be looking at this block. This is now valid, it's got the correct tag, and now we need to see what if this is in the range. So this is 3C. So we have 3 BABC, and this is in the data range here, and this is in range. So we hit this block and we would get the data back. So when it is in the cache, a hit occurs and we just read the data from the cache. Now, the tag must match the block for the block index, so you could imagine this is independent of this index here. So this index could be 3 or it could be 2. Let's say it's 2, then we would look to this block, but this could be something like BC, and that is not the same tag. It would not be in this range, and so it wouldn't be a hit. So let's look at some more examples. So let's say BC30. So we have a different tag, so it won't be in this one. Let's look at our index. It takes us to block 0, which did not have a valid block, but when we get this access request, BC30, we go to block 0, we put the tag in of BC, and we subtract the offset to get the range. So we're subtracting 3 from BC30, so this gets us down to BC00, and then we add 3F, which is 63, on to get the range of data. So we get BC00 to BC3F. This is what we get from memory, because this would of course have been a miss because previously there was nothing in block 0. So when we get this access request, we need to refresh block 0. But that's how we determine what the range is, what the tag is, and the block. And the valid bit is now set, so if we got another request, then we would have some data in block 0 of the cache. So let's get another access request. So BC04. So the index is 0, so we go to block 0. It is now valid. Has it got the right tag? Well, yes, this is BC. These match up, so we have the right tag. And then we need to check, are we in the right range? So we're BC04, this data is indeed in range, so we'd hit block 0. Happy days. So let's have another look at another one. So we get BCA8, that gives us a tag of, or not a tag, a block of 10, so that's 2. So we go to 2, and let's have a look at what we were previously at. Previously had BC, or BA, so when we get BC, the tag is of course not going to match, so this won't be a hit. We won't get any information out yet. What we'll have to do is refresh the block with BCA8. Now we subtract 8 from this because that's the offset, so we get BC80, and then we add 3F onto that to get the upper range. So we load the data from memory of BC80 to BCBF. So this is miss refresh block 2, because originally we couldn't miss, we didn't have the right tag, we weren't in range of the data, so we must refresh that to get new data into the cache. Okay, so let's do more examples of this. So we have the same setup, 16-bit addresses, 4 64-byte blocks in the cache, tag is 8 bits, index is 2 bits, and offset 6 bits. So we start off with this setup. So let's try and figure this out. Is there a cache hit or a cache miss? Let's see what happens. Well, we have BBFFC, or BBFC. So we know that if we expand FF out, we will get a value of 11 for the index, so we'll have to go to block 3. And of course, beforehand, we didn't have anything in block 3, so there's nothing here, the valid bit is not set, so no matter what happens is we're going to have a miss. We're going to look to it, and we're going to say, okay, there's no information in there, so we're going to have to refresh block 3. So, how do we do that? Well, we expand it as a binary number. We have our tag, which is going to be BB, so our tag goes in there. It's now valid because we're going to refresh the block and get memory from main memory. And we subtract the offset from the original value, so we subtract 2 from F, so that'll get us down to D. Will get us down to C. Yeah, it'll get us down to C, so we'll subtract, no, that's 3, so we'll subtract 3 from F, that'll get us down to C, and then we subtract, that'll be 12, so we'll subtract C from C, so we'll get BB, C0, and then we'll add 3F to that to get up to FF. So we've refreshed the block. Now we go to the next one. So BC00, so 00, that means that our block is going to be 0, so block 0 will have to either be refreshed or we'll have to get something from block 0. So again, we would just have a look. Do we have the same tag? We do have the same tag, and so we should get a hit, and we do get a hit in block 0. So let's have a look at the next one, which is BCA1. So A would be 1010, so the index would be 10, so we'll get block 2. So block 2 has valid information in it. It has a tag of BC, and it has a range of BC80 to BCBF. So we access BCA8, block 2, and this will be a hit because it's in range and it has the correct tag. So then we go on to the next one. Now B is 1011, so we'll have a tag of 10 again, or not a tag, sorry, an index of 10, so we'll be looking at block 2. However, we don't have a matching tag, so this will be a miss, and we'll refresh this block. Then we need to figure out what the range is, so we'll have 1, so we'll subtract 3 from the B here, so that'll get us down to 8. And then we'll need to subtract B from B, so we'll have 80, or BB80, and then add 3F onto that to get BBFF, or BBBFF. So we miss, but we refresh block 2. Now, I hope this makes sense to you. It can be a little bit confusing working with the index offsets and tags, but it gets a little bit more straightforward with practice, which we should have plenty of in the tutorial this week. So that's everything I wanted to go over. I hope you found this useful. If you have any questions about anything I've covered here today, please do let me know. Thanks.